Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Linear PIP24VDCRU is what this is. This is a plug-in. They call it a power supply. I'd call it a transformer as well. Auto resetting polyfuse, they indicate on this, which is probably the advanced feature, I would say, that tells us it's a power supply. A transformer literally just does only that. This is a power supply in the sense that it is doing the transforming of power, in this case, from 110, 120 VAC down to 24 VDC, and in the process it's also rectifying the power to permit you to connect to the 120 VAC input to a DC load. Electric strike would be a load, would be an example of a load. Anything that is requiring power to operate is the load. You have those four basic components. The four basic components in an electrical circuit would be load, your lock. Let's just say in this client we have our, it's an electric strike. So the load, the switch, what controls it, open, close, cut power, allow power, open circuit, closed circuit, whatever it is. So the switch, you have the conductor. It's literally the wires that connect everything. Then you have the energy source, and that's where this piece comes in. It's providing the power through the conductors, controlled through the switch to the load. And this is one of those four components. Those components, again, are switch, conductor, load, and then your power supply, your source of power. And you need all four of those to make something work. Another simple tip when it comes to electrified hardware is whether it's normally closed or normally open. Also thought of as fail secure or fail safe. That's defined when the hardware comes out of the box and you hold it in your hand. What is its natural state? What does it do when you just take it out? Is the electric strike always, is the keeper rigid or is it open? If it's rigid, it would be considered a fail secure, or that would be a normally open sort of circuit arrangement, because when the power is cut, it's locked. When it fails secure. The exact opposite of that would be an electromagnetic lock, where you take the hardware out of the box and take the plate and put it together and it doesn't stick to it. Okay, so that's fail safe. So that would be a normally open circuit as well, in the sense that you need power to power it. But when that power is cut, it's fail safe and the part no longer works the way it's intended to work once power is applied. Back to the electric strike, you could have a fail safe, where that would be a condition where you have power requiring to run continuously through the circuit to power the strike so that it stays locked. Upon loss of power, that would be unlocked, and so therefore fail safe. The normally open, normally closed really applies to a switch in terms of, if it's normally open, then when you take the hardware out of the box, power is not going to flow. Okay, you have to do something to that to close the circuit in order for the power to flow. If it's normally closed, then you're going to be continually running power through it until something happens. A good example of normally open, normally closed would be a door position switch. So think of the airport. When you're walking through the terminal, there are doors that go out to the jetway. Those doors for sure are controlled by not only alarm over exit devices, but for sure door position switches. So you can have a door position switch where it's normally closed until you open the door and it breaks the circuit. That will certainly do something, at a control panel, at an access control. Something is being tracked, audited, an entry is written. You can also have that same door position switch where, it's normally open, but when you close the door, it will close the circuit. Okay, so you might be able to have something occurring. Let's say you wanted to have an annunciator at the opening, and when that door is opened, let's say that you are normally closed. Pardon me. Let's say that you're normally open, but when you open that door, that circuit becomes closed, powering that circuit, therefore having an annunciator run. Okay, so you could have it when that door is open, the circuit is then closed, permitting power to run through, and then something else to happen. A light goes off, and an alarm goes off, an annunciator. So, not to get too far aside, this is just a plug-in transformer. Power supply is what it is. You're going to plug it into an outlet, and it's going to give you, it's going to give you 24 VDC output is what it's going to give you. Let's take a look at that. Indeed, 24 VDC output. It has its ground here as well. Ground prong on the AC power input and ground output terminal provides input protection and easy panel ground connection. Okay. That also is a feature that makes this a power supply and not just a transformer. Output voltage regulated at plus or minus 1% from 0 to 100% load. Expands options for use in low load and high load applications, so it's a very fine piece of equipment in that regard. Polyfuse automatically resets after a short circuit, prevents unnecessary service calls. Ground plug on the AC we talked about for input and output protection. Robust surge protection prevents AC line spikes and transients from harming the power supply or the connected equipment. I'd like to get the camera to focus on our label that's here. There we go. Suppose you can pause this video if you need. Okay. Red LED power indicator, that's down here in the corner, shows at a glance that the power supply is operating. That's handy as well. Plugs directly into an AC outlet. Knockout for wall outlet retaining screw here. Quick and easy to install. Acts as a transformer and a power supply in one. No cabinet to mount. They give some dimensions. 2.5-inch wide. I would say basically yes. 3.5-inch height. Closer to 3.25. 2.25 deep. Let's say that it would be closer to 2.125. Okay. Well, here's what's important to know. The output is 1 amp max. So what that means is you have to make sure that whatever you're powering will be operating at not more than 650 milliamps. You need a 50% margin, really, is the design. So whatever you're going to power, make sure it doesn't exceed 65% of an amp, or 650 milliamps, because 650 times 1.5 is going to be, awfully close to 1 amp. I'm just guessing, 6.5 times 1.5. Yeah, 975 milliamps. You have to be mindful, though, of the inrush requirement of your equipment, if there is one. I was just working on last week an electric deadbolt by SDC that required, 0.4 amp. Something reasonable that you would expect, but it had an inrush requirement of 2.5 amps. Okay, so this would not work for that. So you've got to have a power supply with that, where you're able to provide that 2.5 amp inrush that this is that required. I'm powering an electric strike with this that does not exceed what this can deliver safely. Okay, so you'll want to think of your entire system when you are when you're not only looking at your hardware, but what power do you have to supply? What are you going to have to bring to it to safely power the entire system? Typical power supply, typical plug-in style. Plug-in style, you can also have this hardwired, but listen, there are instances when plug it in the wall, you're done. This is also UL and ULC listed, so this is compliant with Class 2 power supplies for dry locations. Okay. FCC compliant for Class B devices as well. those certifications are mentioned down below. The name Linear is one that is a very broad name. I know of them, one part that they work on, they supply operators for gates. So if you have a gated community, and a residential development gated community, Nortec or Linear provides, the operators to open those gates. That's one small aspect of what we get into very occasionally. Do we work with that product line? If you have any questions on the Linear, this is their part number PIP24VDCRU plug-in transformer power supply, or any other Linear product, please feel free to reach out to us. And thank you.